Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.
I'm Dr. Frederick Burtley, scientist and President and CEO of COSI. Welcome to QED with me, Dr. B. Let's talk about science.
Dr. B, I'm excited about today because we're talking about the intersection of science and art. I would have to say one of my favorite types of art is watercolor. I know it seems kind of simple, but I love what it does with landscapes. I love the subtlety of colors that you can capture, and it really is an artistry of the brush. Dr. B, what about you? What's your favorite type of art?
My favorite artist, hands down, is Jean-Michel Basquiat. He has such a vivid social commentary of what's happening in the world and just really, really great content.
Today we're exploring this remarkable intersection of science and art with something that's unique and fascinating, glass. There's actually a lot of science that goes into glass making and glass blowing. And if you look through the history of glass, there's a lot of techniques that we still use today. And there's actually a lot of pieces that have survived history.
We have glass vessels, jars, artwork from civilizations through the course of history. We even have artwork as early as 1500 BC. The Lycurgus cup is a great example of an ancient culture really understanding the science that went into glass making while making something truly artistic. It's a 4th century AD Roman chalice that depicts the mythical king Lycurgus, made from glass that was impregnated with silver and gold nanoparticles. These are small bits of silver and gold down to less than 50 nanometers in size. And what's really neat about this cup is it's dichroic. It looks different colors depending on if light is passing through it or not. Sometimes it looks green normally, but when lit up from the back, it is red. This is just one example of the amazing glass art we have dating back thousands of years through history. To hear more about the history of glass and to see some of these phenomenal pieces, we actually went over to Toledo and heard from Diane Wright, the curator of glass at the Toledo Museum of Art.
Glass has a very long history. We know that people were making glass from about the 15th century BC. And for about the first 1500 years, they were making very small objects that were used in a luxury way. So they would make small jars for things like makeup and oils, small pieces that would be inlaid in furniture. So we're looking at some of the earliest glass vessels that were made. They are from Egypt, and these are vessels that we call core-formed because they were not blown. They were made in this process where you would use a central core of material, probably some dung or something organic, and you would wrap the glass around it, and then once it was cooled, you would pick that core out. That process actually really kind of demanded that the object be made very small. And objects like these would have been used to hold makeup or scented oils. It wasn't until about somewhere between 50 BC and 50 AD that somebody along the Levantine coast developed what we know today as glass blowing. And that really revolutionized and really changed glassmaking because now you could make things that were much larger, you could make a variety of shapes and sizes, you could use molds to make things that were consistently shaped as well. So this is a wonderful example of an early blown piece from the 2nd century AD. And this really gives you a nice comparison between some of those early Egyptian vessels in terms of scale. So this piece is very large. And it was blown by using a blowpipe and a maker dipping that blowpipe into molten glass and expanding it, blowing a bubble, expanding it, and then using tools to create the shape, and then later adding the handles and creating a lid that would fit onto this object. Another technology that really changed the way we make glass actually happened here in the United States in the early 19th century, and that was the development of what we call the glass press. This machine, which would have used some humans to press the glass, really changed our ability to make glass in terms of making it faster and making it, honestly, with a little less skill than a glass blower would have. So you could train somebody how to use this machine a lot faster than you could teach somebody how to be an expert glass blower. With a glass press, you need to have a mold. And so the mold maker is another person who has a lot of skill. And the mold will allow you to create the shape of the glass and the decoration on the glass at the same time. So again, it speeds up the process because you don't have to have a separate skilled person who can cut the glass or engrave the glass or do whatever kind of decoration you want on the glass. In the second half of the 19th century, glass companies actually were moving into the Midwest to take advantage of natural resources like sand and natural gas, which is specifically important to glass companies, and also to take advantage of space and transportation, the railroad, and workers that might be here as well. And there were hundreds of glass companies in this area. By the late 1880s, in the press, you could read about Toledo as the Glass City. The studio art movement in glass is often talked about in terms of its origins here in Toledo, Ohio. In the mid-20th century, there wasn't anywhere you could go and take a class at a university in glassmaking, and there was a man named Harvey Littleton who was teaching ceramics here at the Toledo Museum of Art. And he had wanted to hold a workshop where artists could come in and experiment with the material. So Otto Whitman, the director then at the museum, gave him some space here on our campus. Harvey invited a number of people, ceramics professors from around the country, to come. They built a furnace with the help of a local retired scientist, Dominic Labino. And this group of people came together in 1962 and just began to experiment with the material. And this is really this watershed moment where experimentation with glass as a material for art making really begins here in the United States. So here's a work by Dominic Labino called Vitrana. It's made up of 33 panels of glass that are cast. He was a scientist at a factory called Johns Manville, a fiberglass factory. And when he retired, he started a second career as an artist making glass. And he's really important also to kind of understanding how experimental people were being with glass in the 1960s and 70s. It really just shows you how interested he was in color and that idea of working with his knowledge of chemistry into his artwork. And the color in glass is really all about the chemistry. So you put different minerals in the glass and you get different colors. A really simple example of that is something like cobalt. So cobalt makes a blue glass. Green and yellow can result from the presence of copper in glass. You can get red from using gold in glass. And so understanding the chemistry then becomes vital to getting the color of glass that you want. I think people are really drawn to glass. It really is a material that just does things that no other material does. Whether it's wanting to pick up that beautiful stemmed goblet and have a glass of wine out of it, or whether it's wanting to have a big window in your kitchen so that you can look out and see the world, or whether it's driving your car and having this material that allows you to travel in the way that we do today, or whether it's picking up your phone and looking at the screen. Artists love what it does with light, and we love what it does maybe in just facilitating our daily lives.
Wow, I really love that Toledo, Ohio is called the Glass City. And how cool is it that the museum brought in this local scientist to build this furnace and teach these classes and workshops to help glassmakers better understand this medium? I mean, this really is a great example of where science and art intersect.
Colored glass is all about chemistry, that's for sure. Diane talked about using cobalt to turn glass blue and copper to make green and yellow colors. Medieval cultures used similar knowledge to make the beautiful stained glass windows we see in churches that have survived as early as the 10th century CE.
It's interesting how much ancient cultures understood about glass making. I mean, today with manufacturing and automation, we really can produce a lot more glass, but it's also interesting that artists are still using similar blowpipes that they did 1,000 years ago.
There's not just science that goes into glass making, but a whole lot of technical know-how and, of course, artistry. It could take years to become a highly trained glass artist. For more on that, I spoke with Forge Garabrandt from the Franklin Park Conservatory, who walked me through the process of making a glass bowl. Forge, so good to meet you.
You too.
Listen, it's hot in here, but we're about to do some really cool stuff.
Yes, we
We're
are.
about to make glass, right?
Yes.
So first of all, what is glass made of?
So it starts out as silica, which is sand, and calcium and sodium carbonate.
Let's get right to it.
So we'll start off with doing some safety stuff with glasses.
Thank you for the safety first.
And I'm gonna take a gather of glass. This is our blowpipe. So this furnace is at 2100 degrees, and we just wind it up on the tip of the pipe like honey.
Okay. Now we're using two furnaces. This is the first one.
Yes, this is where all of the molten glass sits. It's sitting in a big ceramic pot. And then we're just picking up some color. This is just colored glass that's broken up into little shards, and we call this frit.
Now the first oven was 2,100 degrees. What's the second oven?
This one's a little colder. It's at around 1800 or so.
Oh, colder.
And this just keeps it at a workable temperature. We're just constantly rotating.
And why are you constantly rotating it?
So if I stop rotating, it will just slowly fall off the end of the pipe. As it heats up, it moves around a little more. So you kind of have to keep up with it. So we're using a wooden tool that we keep soaked in water all the time.
Okay. And the water just helps cool it?
This cools it down, but it also is making it symmetrical and condensing it a little bit. We're trying to get it to a nice temperature so that we have a good amount of control over it. Then we'll start to add some air. Make that a little bigger. And then we need to make a spot where we can take it off the pipe. We have to make a weak spot where we can actually break it off. So I'm gonna start to put a little constriction up here at the top.
Oh, I see it. Groove. Now the color changed from orange based to now blue based.
Yeah, so while it's really hot, it's all just going to look like that bright orange. And then as it cools down, the colors are gonna start to come out. But it's actually not gonna be true until it completely cools down to room temperature. All right, I'm gonna hang this up. We take a big gather of glass, and I'm just gonna drop that on the table. It's so hot, it's gonna make a nice little circle. And we'll stick that to the base. This will be the foot it sits on. So now we'll get another pipe ready. We'll stick this to the base. Then we put a little bit of water on the top, right on that line. So it knows right where it should break. I tap the rod, and it pops off.
That was awesome.
But we gotta get that right back to the heat or else it could crack. Start to put some upwards pressure on there. And that just slowly starts to open up the vessel. But it cools down very fast. You only get maybe like 20 seconds to really work with it. So as I turn, it wants to just flare open on the edge of this. So now that it's open all the way, as I heat this up, it's just gonna try to flare open. And I'm gonna start to spin a little faster. And we just let that flare. And then we let gravity do the rest. Give it those wavy edges. We'll put a little bit of water on the base, so that'll tell it right where to break. It creates a little bit of thermal shock. Then it should just take a little tap to pop that off.
So now it's not finished. Apparently you're putting it in a kiln.
Yes.
What does the kiln do?
The kiln is going to keep this at about 900 degrees.
Okay.
So this is going to hold it at a steady temperature so that it doesn't crack. And then when I leave today, I'm going to send that down on a cycle for about 12 hours. So that's going to cool it down slowly over that time.
So we started at 2,000 degrees Fahrenheit to get the glass. We shaped it at about 1,800 degrees Fahrenheit.
Yes.
And now we're curing it in a kiln at around 900 degrees Fahrenheit. But for about 12 hours, what's happening over 12 hours?
So it's just cooling it down slowly over that time. And that takes a lot of the stress off of the glass. If it would have stayed out here for another minute or so, it would have just dropped in temperature way too fast, and then it would have cracked and fell apart.
That's the coolest example of the intersection of science and art.
Awesome.
Wow, I'm so impressed by how easy Forge made that look, but when you think about it, glassmaking seems kind of strenuous. You have this hot furnace, you're moving around glass with these metal poles, you have to shape the glass. But it's not just knowing what to do and when. Forge really had to know the science behind the glass blowing.
Forge definitely knew the science. He talked about the silica used to make the glass, and he mentioned that sodium carbonate and calcium carbonate are added as well. The silica is the main component of the glass, and it's usually made up of sand. It's actually called the former because it makes up the majority of the final glass product. They add sodium carbonate to lower the melting temperature of the glass, and then add calcium carbonate as a stabilizer. It makes the glass stronger and resistant to water and humidity.
There's really a lot of science that goes into all aspects of glass making. But science isn't just used to make glass. There's actually a lot of scientists using glass in their work.
So true, Diana. Chemistry, physics, and biology use a lot of glass apparatus. One of the reasons is glass is very inert, so it won't react with the chemicals, making it an ideal product for laboratory work. You see, scientists take advantage of that as they often require unique pieces of glass for very specific experiments and tasks. To find out more, I talked with Tim Henthorne, the senior glassblower at the Scientific Glassblowing Lab for the Department of Chemistry and Biochemistry right here at The Ohio State University. Most of us know of glass blowing, whether we've done it ourselves or we've seen it in person or seen it on TV or experienced it at an art museum, for example. But you're a scientific glassblower running a scientific glassblowing laboratory. Can you define and distinguish what that is?
A scientific glassblower is someone who meets the needs of researchers in the form of glass. They can execute the chemistry, the physics, the mechanical engineering, chemical engineering, the epidemiology. All of these different sciences have to have a way to explore what they're interested in, and glass aids them in that, especially here at Ohio State, because we have a tremendous research community, and glass becomes a part of that, just like any other material.
Why is glass the preferred choice for most labware?
Well, initially glass was a wonderful material for chemistry because it doesn't react with the reactions that are done in the glassware.
So not very reactive, so therefore safe.
The glass that was used to make laboratory ware was called soda lime glass. And those were the earliest forms of glass that were available to use for everything, including windows and for any kind of scientific device. And I'm talking about back in the 19th century. But somebody came along and invented borosilicate glass. And this particular type of glass can also deal with thermal stress. The beautiful thing about borosilicate glass is that it comes in tubes and rod form that are already fabricated for us to keep on the shelf to use as our stock. And then we're able to reheat it, reshape it, change it into what one of our projects demands.
So there's a lot of labs around the world, a ton of glassware, everything from beaker to an Erlenmeyer flask to then these more sophisticated kind of distillers. Is all the glass blown, or are some of them manufactured?
In the industry, there's called disposable glassware. And most of those items are, for example, like beakers, pipettes, test tubes, common laboratory glassware that serves a purpose, but it's not a specialized purpose. So that stuff, they use it, they break it, they trash it. It's got very low value. Then we have, our specialized glassware. And we actually have factories that fabricate standard scientific glassware. Not everything is being manufactured. So that's where we come in. And not everything that is manufactured is suitable for the application. So they'll come and we'll either modify it or we'll make something of their own custom design. Do a drawing, we'll come up with an idea that we hope will satisfy the need of the research. And then we'll basically just follow the instructions and make it. Sometimes it's a challenge to do what they want you to do. And that, to me, is the beauty of it. This, for example, is an apparatus for the Department of Epidemiology. It's a reproduction of a hookah pipe. And the part that I make is the top part, we call it the bowl, and the tobacco is actually put in this part here. I also modify this type of flask. It's a 2,000 ml disposable flask, like our disposable glassware we talked about earlier. They're testing the smoke that comes off of the apparatus to see how it might affect the human body, in harmful ways. The convenience of me being here is that actually this is the first generation of this particular apparatus. The top part here, for example, the initial design was to have these holes installed in the bottom. That was a problem because the liquid from the use of the bowl would flow down into the bottom of the rest of the apparatus. And we redesigned it, and the holes ended up being installed in the inner wall here so that none of the liquid would pass through the cavity of the bowl. So we built a kind of a final design over the course of time. The first prototype, the second prototype, and then finally we're really satisfied with that. We're gonna keep it. So then I photograph it and I'll keep all of those records in a PDF for that particular professor. And then it's a wonderful thing to have a computer with, all of these details already worked out. And it saves a lot of time.
And what do you see as the future for glass blowing in the scientific context?
One of the problems with computers is that they can't model everything. So they still have to go to the lab and use glassware to get an end result, a physical result. But I think the future is great. I think if I wanted to work until I'm 90 years old, this job would still be available to me.
You built a career out of this. I'm looking at both sides. How did you get into glass blowing and your interest in this field?
Well, I'm actually a third generation, and you'll find that there are a lot of us out there that their fathers or their grandfathers were in this profession before them. However, it's not the only way to get into the profession, but for me, my father had a little shop in the basement. He made, trinkets and that sort of thing, and I was around it all the time as I grew up, and one thing led to another, and I became a scientific glassblower as well.
So as someone who both has in your DNA, but also operates a lab at a basic science research and has dabbled both in the art side and the science side, what would you share, what advice could you give to the average person to be interested or how they should think about science?
Think about everything around you, everything in your environment and how it arrived in your life. You can look at the simplest things. For instance, your drinking glass. How did it arrive in your life? Was it manufactured in a factory? Was it, pressed in a mold? These are the kinds of things that can draw your attention to where something came from. Usually it came from something to do with science.
Thank you so much for spending time with us on QED with Dr. B. It was a pleasure to have you on our show.
You're welcome. Thanks for having me.
My takeaway from today's show is that glass is this amazing material that truly embodies the special intersection between science and art. There's really a lot that goes into glass. There's the science behind the materials, there's the technology in the manufacturing, and there's also all the work that goes into making these individual glass pieces. And just like all of our experts said, that glass really is a big part of our everyday lives. Dr. B, what about you? What's your takeaway?
Science is truly everywhere and for everyone. And that intersection between art and science cannot be overstated. Glass is no exception and such a unique, beautiful material. It's found in art products and our everyday lives. Glass also has these amazing properties that are useful to scientists, both in how we create new tools that help move the scientific field forward, as well as the data we get by having access to glass as a rich technology. It really is fascinating. And that's QED with Dr. B. That's me. Join us on Facebook, Instagram, and Twitter, and we'll see you next time.
Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.